Hello, my friends. I hope you have had a great week. In this live, I'm going to explain about input-output mapping in TIA Portal. First, let me type title of this live. Okay, my friends, do you have any idea, any question? Well, let's start today's live. At the end of live, I will be here to answer your questions. First, let me share a video with you. Give me just a moment, please. Okay, I already shared a video with you. In this video, I'll show you a simple way of input-output mapping in TIA Portal. As you see, I'm using an S7-1200 CPU with an analog input module. If I right-click on my CPU and click on the properties icon, I can see my properties of my CPU, and if I click on this tab, I can see my available input-output addresses. In this live, I used some of them, and I've defined already some tags for these addresses. All right. Some digital inputs, digital outputs, and I have two analog inputs. If I click on show all tags, I can see my tags. And this is my simple program. My friend, this is the usual way to write a program. In this simple program, I use the direct addresses I0.0, I0.1, Q0.0. What we can do if these addresses are changed? For example, I use the start command from another digital input. The first solution is modifying these addresses. But what about if you have lots of input-output addresses and you have a change and you have a different addresses with a large change. Another way to modifying addresses is using this option, rewire tag. This way is usable for projects which have some inputs and outputs, not the inputs and outputs. and when you want to modify one, 2, or 3 tags. All right, the address of 1, 2, or 3 tags. Another way is using a data block for mapping inputs and outputs addresses in your project. So in this video, I'm going to use this way. I'm going to show you this method. First, let's create a data block. This data block is used to store my inputs and also my outputs. Okay, let's click on the OK button. Here, I can define my inputs and outputs again. So let me show my current tag tables on the right side, and then define my necessary variables based on my inputs and outputs inside my data blocks. I define a new structure with this name inputs, and then define three parameters, three variables corresponding to these three digital inputs. Now let's create another structure whose name is output, and then define two variables corresponding to these two digital outputs, Q underline motor and Q underline alarm. I need another structure for my analog inputs. In my hardware, I have two analog inputs. As you see, I can structure my variables inside the data block easily. I can define some structure and then define my parameters. In my program, I use also a bit memory. So let's define another structure with this name parameters and define one variable with bit memory 1 name, whose data type is Boolean. Similarly, you can define other parameters you need in your program for your projects. Okay, let me modify my structures names, digital inputs, modify this one output to digital outputs. All right. So my data block is an area to store my inputs and outputs. Now I need a function. I need a function and FC block to write a program to send my inputs to my data blocks and then send some of parameters of my data blocks to my PLC's outputs. Let's select SCL language. I can write my program in this language very easy. In a very short program, in very short code. All right. My friends, I explained SCL language during one of our previous live. Okay. First, I want to store my digital inputs in some parameters of my data blocks. So here you can see my data blocks parameters. I can easily drag it to my function block. Then I just add a colon and an equal sign, and then select my desired digital inputs and drag it to my program. That's finished. The first and finally, I need to add a column to finish this line of my program. The first line of my program sends the first digital input with this tag to this address in my data block. Similarly, I can store my second input I underline stop in this address of my data block. Now let's do this process for my first digital input, whose name is I underline file. Another tips that can be help you is that if your details view panel is already open, when you click a block a program here, you can see it's inside your blocks. For example, if you for here I select my default tag tables. Now I can see its tags inside details view panel. And now I can tag my necessary variables, my necessary digital inputs, outputs to my function easily. Okay, this address is from my data block, and now I can easily tag my digital input to my program. Similarly, I can map all inputs and outputs in my project. In this simple program, these parameters are my inputs, my PLC inputs, which are stored in these addresses of my data block. And the last two lines, these addresses are my data blocks, which are sent to my these two outputs. All right. But as you know, when you run a program in PLC, if you remember from our TIA Portal course, a PLC first read inputs, then write your program, and finally update your output. So let me convert my functions to two functions. First one for reading inputs, and second one for updating outputs. So I already got the last two lines, create a new function, and use them inside a new function whose task is only writing your desired parameters to your PLC outputs. So my second functions only updates my outputs, and my first functions only reading inputs. All right, now let me modify my first function's name. And now let's open main organization block OB1. Okay, now I wanna send my first network to the second one, okay? Inside the first network, I wanna use my first function whose task is reading my PLC's inputs and store them on defined parameters on my data blocks. The test network, which I call function number 2, whose its task is updating my PLC outputs. Now, I wanna modify my program. So instead of using these addresses directly, I use my equivalent addresses from my data block. With this method, when your inputs or output addresses have different changes, input your PLC inputs outputs addresses are changed, then you can easily modify your program only inside your these two functions. You will only need to modify these two functions, and you do not need to change your program. In this live, my program is only include one network, but in a real project, you will face with a lot of inputs and outputs, and when a program includes many networks, many logics. So this method can be useful if you may need to change your PLC input-output addresses. Okay, now I'm downloading my program to my PLC. Well, this process is very common, and I explained during our TIA Portal course. So let's skip this process and let me show you the final result. Based on my program, when I activate a digital input, let me come back my video a little. All right. Now I enabled the first digital inputs. I stopped my video. My friends, when I enabled the first digital input, my first function receives that and stored on this address of my data block. And this address is used in my program to activate one digital output, but indirectly. This address is used in my data block, and my second functions send its value to my to these digital outputs. All right. So if every time these addresses are changed in my project, I won't need to modify my program. I only need to modify the codes inside the first function and the second function. To see a better view, let's see my data block parameters and my input-output addresses. As you see, these three addresses are equivalent to these three addresses in my program, and this output is equivalent to this and this address in my data block is equivalent to this digital output. Now I am changing my input and outputs, and you see these are equivalent together. Now I'm changing my analog input. As you see, these two numbers are equal together. Okay, my friends. In this live, I explained how you can use input-output mapping methods to write your programs. This is a very useful tip for beginner PLC programmer or intermediate, especially for engineers that need to work with real projects. And in a project, they don't know what are the input-output addresses. Okay, my friends, I reached the end of this live. I hope this live be helpful for you. And if you don't have any questions, I will see you in the next week. Thanks for participating in this live. I will see you in the next week.